Okay. All right. We are live now. What's up, Tyler?
Pete, how are you?
So fake.
Dr. P? Is that what you're called here? Dr. P?
No, I'm not that old.
It's like Master P, but it's Dr. P. I don't know if they'll get that reference, but Master P's a rapper.
All right, Master and Niemeyer.
Master P, yeah, I do have a master's degree.
Master degree.
You can call me master. I prefer you don't.
Anyway, all right, guys. Welcome to another episode of Two Men One Cross podcast. My name is Pete. I'm your host. Tyler is right there. Hi, Tyler.
What's up?
Look at him. Okay. All right. Anyway, so before we start every podcast, let's talk about right here. All right, Tyler, what would the Terminator be called in his retirement?
I don't know.
It's called Exterminator.
There's no laugh.
Never mind.
No laugh from that.
It's
You're
so
gonna
lame.
get silence.
Just waiting for your laugh. Okay. Oh, one more. Okay, one more. Let's see if I can get laugh from you.
Let's see.
Dialogue. Dude, I don't know why. My wife is mad at me. What do you do? My wife told me to pick up 6 Sprites from the store. I thought we might need more, so I picked 7 up. That's why. Okay, never mind. All right.
I don't even quite understand that one.
You don't understand it?
I don't quite understand that.
No, his wife asked this guy to pick up Sprites, but this guy picked 7 up. 7 up.
Oh, God forbid. Okay.
Oh my God, you're getting on. You lame. What's going on here?
Well, think about it though. To buy 7 Sprites, you'd have to buy a 6-pack and then an extra 1. Like that doesn't make sense.
Oh, whatever. Okay, just whatever.
Okay.
All right, I'm gonna take you to sports store. All right, I got 2 conversations. So one person say on the left side, "Can I get 12 basketball, please?" This guy say, "Okay." And 12 baseballs. You got it. And 12 soccer balls. All right. Also 12 golf balls. You mean a dozen each? Yes. Nope, just conversation. All right, I want to ask you. So, is there any other English word that show represent the integer, the number? We have a dozen. We have a couple. Anything else you can think of?
A decade.
Decade. 10 years.
A pair.
A pair. Yeah, a pair.
Triplet. A quadruplet. A centuplet.
The what?
An octuplet.
What is that?
That's 8.
Real? Is it for real?
Yeah, this is a real thing.
Anyway, okay. Didn't know that.
A quarter.
A quarter. Okay, a quarter. Okay, that's
I don't know.
half.
Okay.
Anyway, so all right, we're gonna talk about just one of them. So dozen, right? Which is amount of matter. 12 golf ball, 12 baseball, 12 soccer ball, 12 things basically. Got a question for you. Do all 1 dozen of these things weigh the same?
No.
No.
Do they weigh the same? No.
No, right? You can weigh golf ball. I'm just making up the number 12 gram, 24 gram, baseball, I mean double, right? With the triple for soccer balls and so on. Now, let's do this. If I have 12 carbon atoms and 12 water molecules, how much do they weigh? Can we weigh it though?
Can you weigh them? Yeah.
How? Scale?
Bro, you're the chemist. I'm a therapist. I don't do this.
Yeah, my point is, it's actually the problem if you try to get a dozen, a couple atoms, right? Because I mean, you can weigh it. We have no tools to weigh it. If you look at right here, so carbon contains 6 proton and 6 neutron. Each proton and neutron weigh about that gram, 10 to the negative 24, which is really, really small. 12 of them, 6 this and 6 proton, 6 neutron. If you do the math, it's that number. You can see that number on the scale. Same thing with water. Water, God was it, 8 proton, 8 electron, that's oxygen. 8 proton, 8 neutron. Hydrogen got a proton each. If you do the math right here, add them up, it's just that number. My point is, these atoms or molecules are not large enough or not heavy enough that we can weigh it. Does that make sense?
So you can't weigh them, but you know their mass by their position on the periodic table and you can add them up.
Right, but we can weigh them. Okay.
Okay.
So to be able to weigh them, we need a larger number. A dozen is not enough. A couple, even smaller. Decade, 100 is still not even 10 negative 23rd gram each. Or you can't, right? So my point is we need a larger number, not a number, and that come up with here this number. We have the word. So there's an Italian scientist. His name is Amedeo Avogadro. Joking, Avogadro. That's his name. And he come up with a very, very, what, you're gonna laugh?
Like an avocado.
that's my joke. Amedeo Avogadro. So he come up with a very, very large number. Take a look. So he said that 1 mole, like a dozen, like a couple, but he used the word 1 mole. A mole is 6.022 times 10 to 23rd things, particle in things. For example, 1 mole of carbon contains 6.022 times 10 to 23rd atoms, carbon atom. 1 mole of water molecules contains 6.022 times 10 to 23rd molecules, a very large number. Same thing with an iron atom, helium atom, something like that. Avogadro's number is really, really large. How large? I mean, it's really, really massively large. I mean, we can't even imagine it. I'll give you some example here how large it is. Okay, so if you have an orange, let's say medium size, about 6 times 10 23rd oranges. This number, if you line up like on the Earth's surface, it will add up to make a layer to the air about 9 miles. Is that number? Is that large? Does it make sense to you?
Why make it so large? Why not make it 3 to the 10 to the 23rd?
I don't know.
Okay.
Don't ask me that. That's a complex experiment.
That's
Anyway,
avocado. Avocado could answer that question.
Right. My point is this number is really large. All right, it's even more large if you try to do this. All right, Tyler, I think that one day you're gonna be rich. Let's say, like at the end of your lifetime, you have like 6 times 10 to 23rd dollars. Okay, let's say if they give you this number and you spend like luxuriously $1 million per year. yeah, right. Yep, good. Okay. How many years will it take you to spend 6 times 10 23rd dollars? Let's do the math real quick. Now I'm gonna find years. So let's say you have 6 times 10 23rd dollars and you spend, let's say, $1 million a year per year. Do the math right there. It will take you 10 to the 17th year to spend this money. You don't even live that long, do you?
If I had that much money, I might. Or something.
So atoms and molecules are very small, so we need a bigger unit. That's why we have mole, right? Instead of dozen, instead of like a couple, single. Okay, and guess what? When we have this number that large, 6.022 times 10 to the 23rd atoms of carbon, we can put on scale. It's 12 grams. Guess what? It's 12 grams. Yeah. Water molecules, so we have 6.022 times 10 to the 23rd molecules of water. It weighs 18 grams. Iron weighs about 56 grams, and helium weighs 4 grams. To show you example, this is 12 grams of carbon right here. That's 1 mole. 32 grams of sulfur, 1 mole of sulfur look like that. 200 grams of mercury, about that, really heavy. Mercury is metal, it's really heavy, it's dense. That's 1 mole of copper, 1 mole of iron, about that. And this is 1 mole. Yay.
Why so many more oranges than these 4 things?
Why so what?
So many more oranges. Why are there so many more oranges that equal a mole as opposed to carbon?
Oh, no. Well, because the atom is small. 6 times 10 23rd atoms is still really small. Right here, this is 6 times 10 23rd atoms of carbon. But oranges are much bigger.
I see, because it's a bigger compound.
Yeah.
That makes sense. Okay. We're still here, boys and girls. So while Pete's doing that, I'm just going to give you guys a little rendition, something to smooth it over for you. This is the one I just learned the other day. Isn't anybody home in here? It's
getting cold, so I just don't care. So I'm gonna find something else to do. Take a really good look at me. 22 and I still don't see why all of you people can't get along anymore. 'Cause falling down was so hard to do. Your only crutch was that bottom boom. So I'm gonna find something else to do. 'Cause if I ever was to say to you all the things that I wanted you to love, I'm gonna find something else to do. So I'm gonna stand here by your fire, 'cause it's a cold night.
Recording, so let's make this happen. We're doing great.
Recording. Oh my God.
Yeah, that's what I'm saying. I gave him a little concert. The people are gonna love me. I accept tips, Cash App, NEIM, 91.
Hey, my
Fill it up.
Hey. Oh my God. Okay, all right. So we got right here a mole, right? Okay, so basically this Emilio Avogadro, so this guy right here. So he came up with this large quantity. Okay, so the definition is Avogadro's number is 6.022 times 10^23 things like atoms, molecules, whatever per 1 mole. Okay, the question is, how do we determine this number? That's what we want to find out. All right, let's do this. Oh. All right, let's do this. So to determine Avogadro's number, we kind of go backward, right? We're going to go with a definition. So to find this number, if you, let's say if you have some amount of atoms, whatever number that is, if you find how many atoms are there, and if you can find how many moles are in there, basically look at right here. So atoms up here and mole down here. By the definition is anything per 1 mole. So basically what we're going to do, we're going to take atoms at the top and put moles at the bottom. Do the math right there. This number is going to come up as 1 mole. And that is Avogadro's number. Does it make sense to you?
Mm-hmm.
As soon as Tyler makes sense to Tyler. Okay, so this experiment, this is what we're going to do. Okay, you're going to have a stearic acid molecule. So stearic acid is a fatty acid. I'm going to use a block just to show you. There's a bunch of stearic acid in the container. We're going to find how many molecules of stearic acid are there and how many moles are there as well. Well, basically Avogadro's number is anything per 1 mole, right? So we're going to take put molecules at the top and y moles, the B5 from it at the bottom, and x over y, that's per 1 mole. That's Avogadro's number. And we're going to compare this number that we find out to the percent error from a theoretical yield, how off you are. Okay. And that's what we going to figure it out from this this lab. Any question, Tyler?
No, man, crystal clear.
Crystal clear. Okay. All right, part 1 is what we're going to do. Have you seen a pipette before?
Yeah, I've used pipettes.
Pipettes. Have you used that in your work?
Not in my work, but I mean, I have taken chemistry classes.
You did? Oh, you smart guy.
A decade ago, yeah.
Master Niemeyer. Yeah. Anyway, so there are 2 types of pipette, but either one works. So the first, in part 1, we're going to calibrate. We're going to determine how many drops that require to deliver 1 milliliter. Okay, so this is what you're going to do. You're going to take a cyclohexane bottle. It should be like in the lab. You're going to take just small amount of it, about 5 milliliter. About that, that's all you need. Pull up from just 1 pipette, pull the whole thing up, all right? And you're gonna set up pipette right here, put a clamp on it, all right, and leave it like that, okay? At the bottom, you're gonna have a 10 milliliter graduated cylinder, and you're gonna keep adding this cyclohexane into the graduated cylinder drop by drop until it gets to 1 milliliter. You're gonna keep counting how many drops it takes. Okay, once you get the number of drops, repeat 3 times. All right, you get it, Tyler. What do you have to do?
You got to drop until you reach 1 milliliter.
Okay, all right. It suggests that the number of drops to get to 1 milliliter should be about 100 to 150 for accuracy.
Yeah, that's a lot. I wouldn't have
You
expected
have to
that.
be patient, and you have to repeat total 3 times for accuracy. All right.
Trying to give people carpal tunnel.
And then so you're gonna have one watch glass look like that. You're gonna measure the diameter. What do you use to measure length? What do you use?
To measure length, a ruler.
A ruler. Okay. Yep, a ruler works. Okay. The area of watch glass. Remember the formula of an area? A circle.
Pi r squared. Or
Good job. Pi r squared or pi d over 2 square. D is the diameter. Okay. What's the unit of the watch glass of the area? Well, be careful. If you use centimeter or inch, it's going to be either centimeter square or inch square. Okay. Anyway, that's part 1. I want to take a while, but part 2, shorter but really, really sensitive. Now watch. So you can have your watch glass supported on a beaker. Find something that fits, all right, and make sure the watch glass doesn't like move around. You're gonna fill this watch glass with DI water, deionized water. Okay, UTA will have it for you. Just fill it, and then you're gonna take about 4 to 5 milliliters stearic acid in a clean test tube. Take the pipette, you just calibrate it, pull it up, and same thing, similar setup. Put into the clamp it like that. All right. You're gonna add a drop by drop. Now watch real quick. Drop by drop, drop by drop, drop by drop. Look like that. And you're gonna stop when you see a contact lens like circle, I think, like look like a contact lens on the surface of water. That's when you stop. Okay. So what happened right? Oh, and then you repeat 3 times total. When you add, you're gonna keep counting drops. How many drops it takes you until you see that contact lens? Repeat 3 times total. Okay, and we're gonna go determine the Avogadro's number. All right, that's it. That's our experiment. Should take like an hour, I think, maybe a little bit over an hour total. Okay, now the rest gonna be the calculation. Let's take a look. By definition, Avogadro's number is number of stearic acid molecule, the one that acid that we use today, and over the mole of stearic acid molecules. Let's say X and Y. So we have whatever you did earlier. We have to determine X and Y, put them together, divide them, and you get the answer. Okay. All right. We're gonna start with Y. How do you find mole? Which is a very large number, right? Moles of Y. Okay. The drop that you do, every single drop, that drop right here until you see the contact lens. Do not count the last drop, the one that you see contact lens. Do not count that one. Okay. Count just the one before. We're gonna convert this drop to moles of stearic acid. Here's how we do it. Watch Tyler. It's a little math right here. All right. In part 1, we calibrated the pipette, how many drops it takes to make 1 milliliter. So you're gonna have this number. This is from part 1. Okay. You're gonna see if your number of drop right here times 1 milliliter per drop from part 1, you get the volume. How many drops in here down here? Does it make sense, Tyler?
Mm-hmm.
Okay.
Yeah.
I think it makes sense. Okay. Now from right here, 1 milliliter, we have to convert it to grams. We're going to convert to grams. So we're gonna use the concentration. So you can find concentration. I took it from the handout, but you should see the exact concentration on the bottle. Okay. So if the concentration said, I'll say, in the solution, the stearic acid solution is this gram per 1 milliliter. I put it right here. Milliliter cancel out. You're gonna get to grams of this compound, and the rest is gonna be grams to mole. We use molar mass. Put grams at the bottom, per mole at the top, and you get to moles of stearic acid. And mole is the Y right there. That Y. That's mole. That's how we find wine. Y. Tyler looks really understanding. Look at that.
No, I mean, I never, yeah, this wasn't ever my thing, man. I was more into like social psychology rather than the hard sciences.
Do you feel stressed right now?
I'm a bit anxious, yeah.
Okay, anxious. All right, we talk about anxiety later at the end, so wait for it. All right, next one. Now, a little bit about the before we determine the molecules of steric acid molecules. Let's take a look at steric acid molecule real quick. So this is a fatty acid, it's a long chain carbon with the C double bond OH like the we call hydrophilic head. Yeah, hydrophilic means love water. Okay, and we also have hydrophilic tail, hydrophobic tail. This is hydrophobic means fear. So it doesn't like water. We have a like water part and we have doesn't like water part. Okay. Now, when you drop the steric acid onto water in a watch glass, what is the arrangement of steric acid molecules on water surface? Of course, this is what happens. So it could be, is it like that? Is it like that? Is it like that? Or is it like that?
I think it's like number one.
Number one. Yeah. Why number one though?
Well, because the hydrophilic head is going to, it's like a magnet. It's going to be drawn to the water, while the other one is going to be pushed away from the water.
Marcel Niemeyer, good job. Good job. Good job. All right, so it's going to be just like number one. So this is what happened. All right, I'm going to zoom in real quick. Every drop, put a drop right there. The hydrophilic head go down to the water. The hydrophobic tail pointing up like that. Now, the next drop though, what's going to happen?
Is that what's going to happen?
No. Look at right here.
So
That's hydrophilic head next to the hydrophobic tail. Does it go together?
They're going to repel.
But yeah, like oil and water, it doesn't go together. It slip. It's going to slip, slide on the side. Yeah. And you keep adding, slide to the side, slide to the side, keep adding, slide to the side like that. And go, every drop going to go like that until you fill up the whole surface of the water. It will look like that. Now, the last one though, the ones we call right here, we call monolayer, right? Steric acid monolayer on a water surface. But here's the thing. If I add one more drop on here, well, this guy have no way to go. What's going to happen?
He slides off the side.
Well, you can't slide anymore because there's no way to go anymore, right? Yeah, this is what happened. You're going to start seeing that contact lens we talk about. Yeah, when you see the contact lens, you do not count the last drop. We're going to count the drop, only those drops to make the monolayer. The last drop right here, when you see the contact lens, do not count that drop because of this reason.
So will it actually stack like that though? Like the diagram shows?
It's going to stack something. It's
eventually.
Probably spread out a little, but it's going to stack like that because they have nowhere else to go. Okay. All right. Here we find the molecules of the steric acid. All right. Once you have all steric acid in here, so you can imagine like all steric acid line up like that. All right. So the question is, how do we determine the number of molecules of steric acid on here? Well, this is how we do it. Now watch, Tyler. Watch. So the total area. So we can calculate this number. Okay. If we know how the area that each steric acid occupied, you will know how many steric acid are there. Does that make sense to you?
Yes. You need to know the area of the steric acid and the area of the total plane, and then determine how many steric acids would fit into that plane. Good job. Perfect. Exactly like that. So from the experiment, so we use the molecular model and stuff. Each steric acid molecule take about 21 angstrom square. Angstrom is 10 to negative 10 meter. Anyway, now the total area though, how do you find the total area of the surface of water? The total area of the surface of water, isn't it just the total area of the circle? Good
job. That's what we did earlier. That's why we they measure the diameter of the watch glass, right? And do the calculation right here, and we give you that X. Yeah, basically. All right, summary. What do we do here? You're gonna take like the steric acid solution, keep adding drop by drop by drop, right? We stop the drop when you see the contact lens, and we don't count that drops. The number of drops that make monolayer, you're gonna hit that drop. You can convert that using the number of drop per milliliter. You calibrate it from the part 1 concentration of the steric acid solution and the molar mass of steric acid. You get 2 moles of monolayer and put on Y right there. Okay. For the X can be found from just basically what do you call the geometry, I think, right? It's called geometry. Total area over area of each steric acid molecule, divide them, and you get the number of steric acid molecule. And ta-da! Once you get this number, it should be really, really large. And the real number is 6.022 times 10 to the 23rd. We're going to use percent error to calculate how off you are. Okay, and hopefully you're going to get to that large number. Yeah, basically that's what we do this coming week. Any question?
What a treat.
What a treat. Anyway, all right. So, well, that's the podcast. We always have a fun segment on our podcast. And the next one we call Tyler's Moment. Hey.
Jesus Christ. God, where the hell did you get these?
You're cute. You're so cute. Look at that. I don't know how old you are, but you look really good, man. Amazing. Like,
that's hilarious. Well, bravo.
Anyway, so well, this segment, take away, Tyler. What do you talk about?
Oh, but what am I supposed to talk about here?
We talk about anxiety. Jesus Christ.
Something that's exciting?
Anxiety.
Oh, anxiety.
I'm
Oh,
getting anxious now, dude. Come on.
Well, now I'm a little anxious because you threw these pictures up that I wasn't aware of. So you caught me a bit off guard. I don't know, man. I mean, we wanted to talk about something that people could perhaps relate to.
Yeah.
And I think one of those things that we kind of narrowed it down to was anxiety. And myself, as a mental health professional, I'm a recreational therapist, I see anxiety all the time. It's one of, if not the most common mental illness, often undiagnosed. You know, the thing is, Pete, is like everyone experiences anxiety. Every single person. The thing that makes it different is an anxiety disorder versus just experiencing anxiety are very different, right? An anxiety disorder becomes when anxiety starts to inhibit your like day-to-day functioning. No longer can I do the things that I want to do or think the way that I want to think because this ephemeral thing, anxiety, is getting in the way, right? And, you know, especially with college kids, the prevalence is much higher. You see it much more, you know, in ages 18 to 22-ish. And it makes sense, right? Kids are moving out of their homes where they often had, you know, there was not as many stressors around them. They had, you know, money from their parents. They had transportation. They had friends often. And then moving off to college, it's a changing world, right? You're much more, you have to be more responsible. You have to be much more adult. You don't know as many people. So anxiety starts to build. And then, you know, coming off of the pandemic, right, where we were all secluded for so damn long, you know, the anxiety coming off that, it just kind of aggregates things. So whenever I used to teach, and now this was pre-pandemic, but it holds true now, and things that I tell my clients, you know, there's a couple of things that are like insanely easy to do that help to manage anxiety. Number one is just being outside. Now that can mean taking your computer outside instead of working in an office or in a library or in a coffee shop. Go sit outside, be in green space for 15 to 30 minutes. Okay, you're going to notice a decrease in anxiety. Typically, the best dosage of that is to do that a couple of times a day, every day. Now, the other way is the magic pill that no one talks about. The magic pill that no one talks about is exercise. Exercise have so many benefits for us mentally, socially, physiologically, that it's almost inane not to do it. Exercise is a huge factor in reduction of anxiety, especially over time. So those two things I always recommend. And the third, you know, you guys and Pete, you're at an institution as well, right? Counseling is free or of very little charge to you guys through the school. So certainly take advantage of those things while they're still free, because when you get my age, therapy is not as free. So be prepared to spend triple digits on an hour of therapy at some point. So manage it, get it under control. Is that what you wanted me to say? Was that enough?
Yep, they're perfect.
All right. If you guys have questions on anxiety, email me. I mean, I'll give you some sources.
That's true. Okay, thank you, Tyler. Oh, one question though, how do you know? Like, let's say if I have anxiety, but I don't know, is there any test or like how do you know if you have anxiety?
Well, there are many different standardized measures, and there's actually 5 different disorders, 5 different anxiety disorders. The most common one, and the one that I'm kind of was talking about, was generalized anxiety disorder. And that's the one that students tend to feel, right? You feel nervous, your hands may start to sweat, you may palpitate, your heart may speed up a bit. Really, at the end of the day, it's something very worrisome. So something that worries you or bothers you or irks you in some way that's detrimental to your well-being.
Okay, so there's a test. Okay.
There's several standardized tests that measure like levels of anxiety.
Got it. As a level. Got it. Okay. Good to know. Good to know. Well, thank you, Tyler, and for knowledge that he shared with us. All right, so we're gonna close this podcast right here. 2 Minute One Course podcast, Tyler and me. So you can contact us at you can ask about anything about podcast, and don't forget to click like, subscribe, or rate us 5 stars. Leave a comment down below. We're gonna go viral. Yay!
Viral. I got the concert in there. You know we're going viral.
It'll go viral. Good job. All right. I'll see you guys next week then. Goodbye.